Good morning, H coming at you with another tutorial video. This time we're going to be looking at the Revolve tool. The Revolve tool in Autodesk Inventor 2023. Again, this tool is part of the series about the tools that are used to create 3D material. We already have a sketch already completed here. It's a bizarre one. It's weird. We got a lot going on. You can pause the video here for a moment if you wanted to follow along and kind of look at the Revolve tool with us at these different things about what's going on. Or you can just kind of watch and see what the Revolve tool does, but I'll give a moment here for pausing. Perfect. All right. So just a quick pause there. So this sketch of what we got here, we got a rectangle. We got a line coming down this way. We got a circle, another circle. We got this rectangle here. We got a lot going on in this sketch, but this is all about the Revolve tool. So the Revolve tool is kind of the second tool listed here on the ribbon. And it's in the Create tab. So it's going to be used to create 3D material based upon a sketch or profile that has been made. So if we look at the Revolve here, it's the R key, shortcut key on your keyboard. It creates a feature or body by revolving one or more sketch profiles about an axis. Okay, you can revolve profiles through any angle up to 360 degrees, and the axis of revolution can be a part of that profile or offset from it. This is an important thing, which we'll talk about. The profile and the axis must be coplanar, which means they must be on the same plane, right? So if you draw a profile like a circle, the axis, the line of revolution needs to be on the same plane. Okay, so this is big deal. XY plane is what we're looking at. It has to be on the same plane. It must be coplanar. So this is our sketch that we got going on. There's going to be a lot of examples from this one sketch. But we're not going to be able to show them all at the same time with the Revolve tool. But Revolve will open that up, and we're going to look at the properties that are here. So the profiles, we're going to select a profile or more, right? We select one or more profiles. And then this is different because this is an additional thing we have to select in the Revolve tool, right? Then we have to select the axis that we're going to be using, right? So the axis that we're actually going to be using the whole time is going to be the same. It's going to be this vertical line right here that I've highlighted green I just clicked on. That's the axis that we're going to be using this entire time throughout this entire sketch. What's going to make the difference is where the profile is in relation to this line. Okay, that's what's going to give us the different looking styles of revolution that we're going to be seeing. Okay, so the axis of revolution is this line. Now, it doesn't mean there aren't other options in this sketch. This revolution, it could be this line, it could be this line, right? The axis of revolution is just a line. In this particular case, again, we were trying to use this line here. So we're going to select our first profile. First profile we're actually going to select is we're going to start here with this bottom circle here. We're going to select this half circle profile here and not this one. And then we're going to select the axis here. And what's going to happen is going to give us a little preview first. And what is happening is it's taking this shape, this half circle, and it is adding material as it wraps around the axis of revolution, right? So we can type in a degree. This is where we can change directions if we need to symmetrically. Like we can do basically the same kind of directional manipulation that the Revolve tool allowed us to do. If you haven't watched that tutorial, that's also here to watch on the channel. So you can manipulate the direction, of course, this way. And then you can change the degree. Now, this is what I was talking about. The limit is 360 degrees because those are the degrees in a circle, right? Those are all that's there. You can't do any more than that, right? If you type in more than that, it's basically just saying you want yeah, you can't, right? There's an error there. Can't do that out of range, right? So, but that would be the same as just doing 10. Right. And, if you had 370, you're going all the way around and then 10 more. So 360 degrees is your maximum rotation, your maximum distance that you can go. So you can do any number between there. You don't even need to do like, What am I trying to say? A number ending in 0, right? You could make it any number you wanted it to be, and that's what it's going to revolve that amount of material around. And it's measuring this from the sketch plane from here. So the profile itself is the half circle. It gets revolved around the axis that is there until, for whatever amount we need it to be, right? And that's how the revolve tool works. So this particular like profile here, if we revolve this all the way around, this would actually make a sphere, right? It's very difficult to see this in Inventor, but this is a sphere object, right? This is spherical, this is a sphere. So that's what this is using Revolution, right? Very, very easy to revolve a sphere this way if you ever need a sphere. So the other things we need to do with this is to kind of experiment with other things we can revolve with this line. So we'll look at this profile here, like this rectangular profile. And not surprising, hopefully, is it's revolving the shape and it will make it into a cylinder, a cylinder shape at 360 degrees. It's going to take that rectangle shape and revolve it all the way around and make that into a cylinder. And again, you can manipulate the amount of degrees, the amount of angle that's there, all that stuff, and that's absolutely fine. Okay. Now, another revolve is instead of in these instances, and this the top rectangle here and the bottom circle here, we were using an revolution axis of revolution that was it's coplanar, but it was also part of the profile, right? To some degree, right? It's inside the profile, kind of splitting up this rectangle to two different profiles, really, right? So we need to acknowledge that, because now we're looking at this circle that's here. This circle here, this profile here, the axis of revolution is not in this profile. It's actually out here. So what's going to happen here is we're going to get a donut, or mathematics called a torus, right? So we're going to get this donut shape, and you can see it's revolving. It's adding material in that shape of a circle all the way around, and the axis is going to be directly in the middle. The axis of revolution is in the center of the whole of the donut. You can kind of see the blue line there. It's right in the middle of that open space, that empty space that is there for this donut shape, right? And if I hit OK, there it is. That's the donut shape there of this particular revolution, right? So the circle is and the line have that spacing. Now, what's interesting about that spacing is it's symmetrical spacing, which just means, let me undo this, which means this dimension here, this 50, right? It's going to go from the center of the circle to the center of the hole, and then another 50 from this center line to the center of the circle of the other side that's being revolved, right? So if I revolve this around, the center of this area here is 50 millimeters away. So we can determine like how large something is going to be, even revolving this way, based upon the dimensions of the sketch. So like if this circle is 50 diameter, it means it's 50 total here, which means it's 25. So it's another 50 here, which means it's an additional 25, right? So we have, 50 plus 50 plus, another 50 on both sides, of 25 and 25, which gives us like 100 millimeters from one side of this like donut shape to the other side of the 3D material. Right, so we can kind of adjust this dimension here and these dimensions here to adjust the size of what the overall revolve needs to be. It's kind of tricky, but that's why these distances are important. Away, how far away it is from the axis of revolution is a big deal. Okay, so you want to make sure that you're following whatever like drawing you're using for a revolution, so that way you have the proper distancing and everything else. Now this rectangle is the same idea. This is the profile, the axis of revolution is the line, but now instead of like the donut shape, we're getting like a ring shape, right? And so again, that's the rectangle is being revolved all the way around. And we still have the same ideas as far as like making sure it has the right direction and the proper angle. It doesn't have to be 360. It could be something else, right? To make sure that you have the shape that you are requiring it to be from whatever it is you're working on, whether from a drawing or from some type of design aspect or design challenge. So this is the Revolve tool, using profiles, using these shapes, and an axis of revolution. You got to use the two together in order to get the design intent of whatever it is you're creating, and using that revolve tool. Very, very useful for objects that have symmetry uh, at a center line axis, like a cylinder type of shape, or anything that has like a symmetry and on a midline. Look at revolve as a possible option to solve those issues and solve those problems. And just like with any of these any of these tools that create, there's also a way to change it so they also do cutting as well. If you revolve something and you're trying to cut material, the behavior will appear here, or in the output it'll appear as, oh, do you want to like add, cut with this or add material with this, like what's the goal, what it is you're trying to accomplish is there. So be aware of that as you can see the different outputs when it comes to cutting or joining, or and all those other things. But until then, thank you all for watching, and you all have a great day.